This is a small demo on Kubeflow. Kubeflow is a project used to work with machine learning on a Kubernetes-based cluster. The fir- let's start with the first component, Jupyter Hub. Jupyter Hub allows you to spawn Jupyter notebooks. Jupyter notebooks in turn allow you to do piecewise execution of code kernels. Let's see how it's set up. When signing in, you have an option to choose a pre-configured image. These images have built-in support for uh, machine learning libraries. They come pre-configured. You're also allowed to set CPU limits, memory limits, and additionally other resource limits such as a GPU limit. I already have the notebook set up. When logging in, the users are greeted with a simplified view of the file system on this path. These are indeed just files present on this cluster. Let's start off with a small demo on a notebook running inside of Jupyter Hub. Jupyter Hub allows piecewise execution of kernels. So indeed, I can execute these kernels one at a time. This kernel in particular takes 5 seconds to execute. This is intended to demo how in a machine learning project things that are time consuming can be skipped with the help of kernel structure in Jupyter Notebook. In this example, this for loop prints out 17 things, but I can tweak that parameter without having to execute this middle step, which takes 5 seconds to execute, allowing us to tweak the view of the model in a real machine learning project without having to execute the time consuming steps in between. It also fully supports markdown based uh, markdown based documentation like so. Any markdown syntax works inside of Jupyter Hub. Things like latex symbols also work. So these are latex symbols, and this is able to execute and show these results in line. Jupyter Hubs also allow you to execute arbitrary shell commands inside and see their output in line. So this is a normal shell command running inside of a Jupyter Hub. This showcases the power of Jupyter Hub and Jupyter Notebooks in general. I will now take you through a real example which showcases training of a GitHub issue summarization model. I have done most of the time consuming steps in advance. Let's get straight to training the data, and these are all generated through code. None of this is preloaded. So I could indeed change this to 2 and this would update as soon as I run this. I'm not going to do it here because of time constraints. So I could indeed, this is a model that's generated by this code. This indeed shows the architecture. I can start a training session by executing this kernel. It's going to run for 7 epochs, which indeed is not that long for a machine learning model, but suffices to showcase the abilities of Jupyter. I have executed this ahead of time, and we can see the results like so. This also showcases the power of Jupyter Hub in that we can do asynchronous executions of these kernels. We can finally evaluate a blue score. A blue score tells you how accurate the model is. I've again done this ahead of time. I have also saved this model, and which will showcase how a model once saved can be downloaded off of a Jupyter notebook. As I mentioned earlier, Jupyter allows you to use terminals. So this is indeed a fully featured terminal. Things like git work inside here, or shell commands work. This should we can see the files once they have been trained are available here. This is the final model. These are the checkpoints. Once this is available here, this can be downloaded off of the pod or uploaded to any arbitrary source. Next, I will move on to the next step of this pipeline, which would be a CI/CD like workflow. So once this model has been trained, the code can be pushed to GitHub. An external program like Jenkins can be used to trigger an Argo workflow, which will train this model, build an image out of it, and serve it using Selden. I have done this ahead of time. This is the machine learning model that has been deployed. This is Selden deployment. Selden adds a custom resource description, which allows you to deploy models onto a Kubernetes cluster as if it's a Kubernetes resource. Once this workflow is done, this will be pushed to a Docker Hub registry. Just to be clear, this takes an input from a GitHub repository and pushes it to a Docker Hub repository like so, which is the finally built image. This is the GitHub repo. Analytics can be obtained through Grafana. Grafana allows you to monitor the status of the cluster using Prometheus. These are pod-wise statistics. There are more statistics available than I'm showing here. But once the model has been deployed, predictions can be analyzed again through Grafana, allowing a unified view. This Python program is a small script which makes a REST request to this pod that is running on my cluster. I will show all the pods running on my cluster first. We can see our model running. These are again all the pods that are available. Argo UI and other such pods which I've already used in this demo. Let us see the logs. I'm going to start an interactive log. I'm going to pull this model through a REST API. The small script merely unpackages an image and queries this model over REST. Going to the slow download speeds, it took a little bit longer than it should have. But you can see the REST request and the response that has been returned. The REST request is a bit unwieldy, so that's why I have written a small Python program like this. If the request to the model is in fact a small piece of text, none of this is required. We can just do a small curl. Just to be clear again, this Python program is merely just unpackaging an image and packaging it up into a REST request. This pod is accessible over REST. We can see this request has been updated in Grafana, showing us more statistics and also showing the success rate of the models that have been deployed. We can see the various services that are also running on this pod, on this cluster. For instance, this ambassador is the main dashboard. TFHub is the Jupyter Hub pod service. Also, these are the steps to create a Kubeflow cluster and also deploy Selden on it. The steps are fairly straightforward and can be automated.